Hello, everyone. The topic of our project is AI-driven computational journalism to generate interesting stories for collegiate sports. Abstract. Computational journalism can be defined as the advanced application of computing algorithms and automation to gather, evaluate, present, and distribute news. Introduction. According to estimates, there is an untapped $15 billion plus opportunity in delivering data driven insights to collegiate sports fans. Sports media makes use of unique trend stories to engage with the fans. A trend in sports is the number of times a player or a team achieves a specified statistic in a game over the total number of games played. The current state of identifying trends has four major pain points. It is manual, inefficient, and tedious. It neglects many unique trends. Media lacks access to cross sports analytical models, and there is no live trend generation. It happens only pre and post the game. Our research objectives are to develop AI-driven computational journalism model capable of identifying trends and a model to identify what trends within the data would be unique to the audience of American college sports media.
Let us now discuss the methodology. The aim of our algorithm is to churn out stories that can be considered interesting enough. Here, we see an example where we have divided the story into its key components. First, we have the entity. Could be a player or a team. Carson Strong here, for example. Up next is the relevant stat. For a quarterback, it is the number of passing touchdowns here. For a running back, this could be total rushing yards. Next, we have a qualifier which would make the story interesting. Here, it is 4 or more passing touchdowns. Lastly, we look at the possible counts of these events and number of successes out of it. Here, that is 3 out of 5. Step 1 is to identify the entity and the stat. Our algorithm offers two possible ways of doing so. First, the user, be it an announcer or a journalist, shall manually select these. Second, the algorithm automatically picks the latest entry. Step 2 is to identify the right qualifier. Based on probability distribution function at the entity stat level, the algorithm shall select levels that are 75th, 90th, 95th, 98th, and 99 percentile. For a passing yards, these levels could be greater than 175 yards, 200 yards, and so on. These can be considered as rare and would make for an interesting story.
Step 3 is to identify rare trends. Once the stat passes the qualifier, we create sequences of different lengths to check if the trend is being formed. In this case, Malik Willis has passed 200 passing yards, and the green line shows that this thing has happened in 4 out of 5 games. The blue line shows the trend has happened in 1 out of 2 games. The red line shows the trend has happened in 2 out of 5 games. Then we compare this trend with a database of all trends that have ever occurred to gauge if a trend is unique. The trend of 4 out of 5 games is very rare. The next step and the final step is to develop a context for the story. Here, our algorithm adds significance and value to our unique trend. It churns out things like what is the occurrence rate of this trend, which means that what is the percentage of this thing happening and why is it rare? And then we try to analyze the rarity in different levels. For example, has this trend ever happened this season? When was the last time this trend occurred in the player's or the team's history? Who was the last player who did the same trend? This is how we try to make the story engaging. Now let's have a look at the result and the final outcome. Our algorithm gives us an output, which is essentially an interesting story. For example, Purdue has more than 3 field goals scored in 6 out of its last 7 games, and this event has never happened. Brian Robinson Jr. has had more than 100 rushing yards in 7 out of 9 games. Last occurrence was by Derrick Henry in 2015 season. Broadcasters can use this algorithm to engage with fans via unique stories. The image on the left shows ESPN using our stories in talk shows to engage with viewers. On the right, you can see how sports bloggers can get massive engagement on Twitter and other platforms using our unique trend stories.
Sports analytics is gaining popularity. Movies like Moneyball have highly been appreciated, and this shows that the trend is likely to grow even further. Our algorithm is developed on the foundation of collegiate football. However, considering the dynamic nature, it can be extended to incorporate other sports like soccer, basketball, baseball. We believe that there is a need for more personalized sentence structure. Further research in NLP is required to ensure proper formatting of entities like players, teams. We would like to thank Professor Yang Wang and our client, Dr. Kiran Shastri from Athlete, who have given us the opportunity to work on this project. Thank you.